Okay, so probably what I'll do today is I'll take you through how the interaction workflow or the IW engine works with database. So till now in the entire design, there was no database at all. So the left-hand side is what was there till today, and in terms of how interaction workflow used to save all the files, but was more of a file operation. And the right-hand side is what we have done with database. And I'll also tell you why we have done that, right? So this is how the existing architecture is. There is an IWE component, which is predominantly deployed in IIS. And what it does is it has the endpoints configured for all the interaction workflows over here, right? So say, for example, your interaction workflow engine is configured in 3 WAS servers. So IWE will have the endpoint of all the 4 WAS servers, right? Now, or rather, where the interaction workflow is deployed. What is WAS? WAS is basically nothing but a web application server. And this is a Java-based component. It's a WAR file, and it can be deployed in any container like a Tomcat, which is the most popular one, or JBoss, or any Java-based web application server, right? Whether it's WebSphere or WebLogic, right? So what happens is whenever any configuration file, or rather, which is a call flow or rules or intent master, any configuration which is configured in the UI, it pushes the entire file. So this basically exposes REST endpoints, and IWUI has the endpoints configured in its property file, which is there in your application configuration.json. That will be there in this specific JSON over here. And what it'll do is it'll try to push these configuration files into all these endpoints, right? So say, for example, it'll push it into this in IWE1, IWE2, IWE3, and IWE4, right? If one IWE fails, IWE will have that map, and then probably it'll alert the user in the endpoint in the UI saying that one of the IWE failed, do you want to try it again, right? So what IWE will do is it will get the entire JSON. First, it'll do 2 things, right? One is it'll parse the entire JSON and keep it in memory so that the response becomes faster whenever the IVR or the TPPV asks for it. Second, it'll also have the entire file stored in a specific location, right? Why we do that is predominantly because when this application server is restarted, when app servers are restarted, it needs to have the files to load back everything back, right, into the memory again. So that's why it will keep all the files in the specific location. Now, these files where the locations are there, that's, I think I've already captured another video where it is there in the property files, right? What is the endpoint that this file needs to be in? So at the end of the day, the IWUI will have the endpoint of all the interaction workflow engines, the IWE, and it will push all the property files or all the JSON configuration files into each of the endpoints, right? Now, and there is no database connection. There is nowhere these files are stored apart from the files over here, right? So the important key aspect over here is all the data is stored in 2 points, in 2 places. One is the file, sorry. One is file, and second is the memory, right? Now, this will only hold good if IWUI actually knows all the endpoints, right? It needs to be aware that if there are 5 engines, IWE engines running, interpreters running, IWUI needs to know all the 5 interpreter endpoints, right? If it doesn't know one endpoint, that interpreter won't get any data. The reason being because once the engine gets the file, it doesn't push, or we do not sync to the other server, right? The reason being, of course, if this server goes down or the IP changes, you cannot have the IP of the other endpoint, right, dynamically. Now, what happened? What needed change when application goes into when scaling options comes. For example, you have horizontal scaling or vertical scaling, right? Or vertical scaling, right? So basically, at the end of the day, in situations where we are deploying with AWS or any cloud-based application service, when you're bringing up a new server, that server wouldn't know or wouldn't have any files, right? Because the server would have, the files would be only there in the initial servers which is up. So what happens is, in the new design, the IWUI needs to know only one endpoint. Again, that endpoint is through a load balancer, through service discovery. So we do a couple of things, right? First, when the IWE comes up, you can have 1, 2, 3, or multiple IWEs or interpreters deployed. And the moment this on start, what happens is, the moment any interpreter comes up, it does a service registry, right? So it basically tells an endpoint that, hey, this is my IP, this is my endpoint, this is the port which I'm running to, and it will inform the service registry that I am up and running, right? So service registry is nothing but a REST endpoint, again, which is configured in the property file of interpreter. In this scenario, what will happen is, the moment this specific IWE comes up, it will actually inform the service registry saying that this is my location, this is who I am, this is my port I'm running. And what IWUI will do is, it will take the interpreter path or interpreter location endpoint from the service registry, and whenever a call flow is saved, it will try to push that that specific configuration or JSON files to that specific endpoint. And this will happen. The service registry is there in all the interpreters, right? So whenever each one of them come, it will inform the service registry that I'm up and running. Now, what IWUI will do is, it will try the first URL, right? If it is up and running, it will stop, right? It will not go and push the configuration files to the other server. It will not do that, right? It will only do if this is not reachable, then it will go and try the other endpoint from the service registry. If that is also not reachable, it will go to the other, and so on and so forth. Now, what different that we have done over here is, there is a new component which is included, which is called as IWDBConnector, which is again a WAR file, which is again written in Java and Spring, right? Now, what this does is, this basically integrates to the database, right? This integrates to the database. So the interaction workflow or the interpreter has an endpoint of the DB connector. Now, DB connector is again a WAR file. It's just it exposes REST services. Generally, the recommended is to deploy it in the same WAR server. You can deploy it in the other server, but again, you need to take care of HA of that. So you just deploy the IWDB connector with that WAR also in the same Tomcat or JBoss, wherever this is deployed, right? Now, what it does is, now IWUI will try to push all the property files, all the configuration files to one interpreter, right? Now, what interpreter will do is the same thing. First, it will try to parse the JSONs, the same thing that it used to do before, and will keep it in memory, right? Second, it will keep the file in the file location itself, right? So next time it can read. And third, what it'll do is, it will actually push the files into a database, right? Now, why we do that is, for example, there was only one interpreter running, and there are no other interpreters running, right? And the second interpreter is brought up after the IW or after the first interpreter is running, or after the first interpreter goes down, the second interpreter is brought up, right? During that time, the interpreter 2 does not have any files. So what it will do is it will have all the interpreters has a JSON file, right? And a configuration saying that do you need to do a database integration. Now in this JSON file, it will have each of the call flow name, each of the intent master, each of the rule master, when it was last updated, and what was the date time of it. If it is empty, it will go to the database, fetch all the configurations, fetch the configuration, and does the same thing again. It's 1 and 2, right? It will not push these configurations into database again, right? Why? Because it is just fetched it from the database. It will not go and push it into the database again. It's just going to get the data from the database, put it into memory, and put it into the file again, right? And also update this master JSON saying that, hey, I've got call flow A, and it was updated on 10th of November, and including a date time stamp, which is long, so that it can go and compare, right? And this holds good for any interpreter which is coming up. Now, for example, in a scenario where the IWUI is pushing a new call flow B into a specific interpreter, right? So in this case, all the other interpreters won't have it. So there is a thread which runs. Basically, what will happen is there's a thread which runs, and it will keep checking the JSON file that it has. Remember the JSON I mentioned? It will check if I have this specific, when was it last updated. It will also go into the database, dip and see what all new changes has been made, what are the last updated date and time. And if I do not have a call flow which is there in the database, and if what it'll do is it'll get that flow from the database and does the same thing again, right? It will go and fetch, update its memory, and update the flat files, and also update back the JSON file saying that I have got the call flow B on 11th of November and so date and time, right? This keeps on going. So the objective is that now we have removed the dependency, or rather the need to have the files in a file path. You can have it in a centralized location like a database, because in AWS, or rather when you're using RDS, AWS will take care of the high availability, right? So database is always available. So it's a centralized location. So when a new interpreter is spun up, right, using a cloud formation or something like that, it'll only need to have this configuration where the database integration is required or not. Certain parameters are there. Once that is done, it'll go and fetch all the files from the database, load it into its memory, and keep it into its file. Why we keep it in file over here? The reason being, if, for example, for some reason the server got rebooted and the database is not reachable, if files are there, it will try to load the configurations again from the files and update back its memory, right? But the response is always given through memory, right? So that's faster. So in this case, in the second approach, now the content is stored in 3 locations: memory, the parsed data, file, the actual call flow files, and database, right? So that's the design that we have done with the database approach, to ensure that when a new interpreter is spun up, or the new interpreter is brought up, it need not have the IWUI again to push back all the call flows again to this interpreter. It can take it from the database. So database becomes the sole, the centerpiece of all these configurations over here. So it's quite easy, to bring up a new interpreter again. When a new interpreter comes up, it will do a service registry. And once the service registry is done, it will go and get all the configuration from the database, load it into its memory, keep the database into a file, and it will not go and update the database, right? It will just go and read it. The database update will be done only by one interpreter, not by all of them. The interpreter which IWUI pushes, that's the interpreter which is going to go and push it into the database. That is precisely the reason why IWUI will not push all the configuration to all the interpreters. The moment it gets a success from one of the interpreters, it will stop and not go to the other one. If this fails, if this fails, it'll go and get the URL from the service registry and go and update. And this IWUI IWInterpreter will do the same thing, whatever I mentioned right now. So that's basically the design that we have done from a database standpoint, and how we have achieved that all the configuration remains centralized in a database, and how this can be used in a mode where AWS or any centralized location has to be used. Again, it doesn't mean that this approach is taken away. This approach still remains as it is, and the entire design, whether to use this or whether to use this, it is defined through a specific configuration files, right? What I'll do is I'll quickly show you those configuration files, so you get to see what these configuration files are all about. As I mentioned, there are two property files. One is the interpreter property file itself. This is the key which says whether it should go and integrate to the database or not to get the files, right? So that's the value. The default value, even if this key is not there, or the key is empty, or the key value is empty, the default value is n, right? If the key is there and the value is y, only then it will do the second design that I talked about, right? You remember the database connector, IWDBConnector, which is again a WAR file, which is again an endpoint. You can actually mention that if it's localhost and the same port, just give this localhost and same port. And that's the database or the DB connector API. It can be in the same server or it can be in a different server. As I mentioned, the best practice is just to keep it in the same server and the same port, right? This is the service registry details, right? So you remember I mentioned that whenever a new interpreter comes up, it needs to inform the service registry that, hey, I'm up and running. That's the service registry for you. As I mentioned, there is another WAR file which is included, which is called the DB connector. The DB connector is basically the one which integrates to the database. The reason of separating these two are, we do not want to make the IWInterpreter heavy, because when a DB connector comes in, you need to load all the database drivers and everything. So the WAR file needs to be lightweight. So approaches where DB is not required, we do not load all these WAR files, and hence we kept it as a separate WAR file. So it supports multiple databases. You can just key in this database type over here. It supports more, but for now, the drivers are loaded only for these 4 databases, right? The database username, connection URL, username, password. I know the password is still in plain, it's not encrypted. And driver class, if it is empty, it will automatically take the default driver class based on the database type. If tomorrow, because the driver class keeps getting deprecated and keeps getting upgraded, you can put this value over here. These are the connection pool settings. You can put it over here. Now, you remember I also told about there's a thread which runs and keeps checking in continuous interval when a new change has been uploaded. That's the interval over here. In how much milliseconds the system or the interpreter or the engine needs to keep checking the database whether there's any new change or not, right? There can be requirement that, for example, you do not want the database to, for example, there can be situations where once the application is loaded, you do not want to keep polling the database again and again. There is a key for that, which we have included. I've not mentioned it over here. There is something called database_polling. And I will equals to y, right? Only if this key is there, it will continuously go and keep checking the database for new changes. If you do not want to do that, if you only want to do it on the startup level, and you do not want every time to keep checking, because in a lot of places in production, the changes, the IWUI is not allowed, right? So if the IWUI is not allowed and no changes are going to be pushed into a production interpreter, you do not want the engines to keep continuously polling the database, right? So you can have this flag and keep it white, and you go and check the database for that, right? Again, this also has a service discovery. Why service discovery is required? You remember all the username, passwords, and all these things. Either you can take it from this configuration file over here, or when service discovery is set to yes, it will go and fetch all the database username, passwords from the service discovery, and update it itself, right? So it need not be hard coded over here, right? So once that flag is service discovery flag is set to yes, it will go and get the service discovery database details and update itself. And again, the service discovery details in terms of what is the endpoint, what is the server and the port, what is the URL, what is the protocol, whether it's HTTP, HTTPS, what's the connection timeout, and if this all will matter if the service discovery is set to yes. So that's more or less on the design in terms of what we have done with interpreter as well as DB connector. Again, these two are separate instances where you do not have this, you already know the number of servers which are there. It's already pre-configured, pre-deployed, like in all the current instances we have. Instances where what we are doing with Synctel and database updates, where you need to spin up a new instance when a cloud in cloud terms. That's where you can have this database connector and have all the configuration centralized in a DB location. So yeah, that's more or less it. Any questions, do feel free to write to me, but I will also include all this configuration files and everything which will be available in SVN. Thank you.